And our next talk is going to be project updates about AMD GPU.jl. So whenever the speaker's ready, you can just get started. We're running like about 2 minutes behind, so just want to keep things moving.
I'll try to run through a little quickly. I do have a few slides. Okay. Good. Thank you. All right. Hello, everyone. This is not a talk written by me. I am taking over for Anton Smirnov, who is the current maintainer of AMDGPU.jl. He wasn't able to make it to JuliaCon this year. I am the original author of AMDGPU.jl. Anton has taken over day-to-day maintenance, but yeah, let's talk about what's new in AMDGPU.jl. That is a mouthful. Okay, so over the last year, we have had a lot of progress in AMD GPU. So there's been about 150 commits from 18 different contributors. That is stellar. That is awesome. Remembering back when I was maintaining it, we did not have as many contributors. That is awesome to see. There's been 31 package releases, and that has been building us up to a 1.0 release, which is awesome. As you can see in this image here from BuildKite, there is 100% reliability in CI. I don't know how that was achieved. That is amazing. But we're basically at the point where no PR gets merged unless CI is green, which is a really nice change. They're testing against official Docker images from AMD upstream and testing on RDNA 3 GPUs, although we do want to get CI running on other GPUs as well, but we'll address that in a little bit. One of the big changes that people will notice is that hardware atomics for floating points is much improved and much faster. So what you can see at the top is an example of using the add atomic macro to increment a value in an array. Before, this was lowering to a cast loop or a compare and swap loop. You do not want to do this. This is not efficient. This is not great. If you have an atomic add instruction, you want to use it. We are now using it. This is awesome to see. This lets you build quite a lot of more advanced algorithms in GPU kernels directly with excellent performance. So enabling this, and one of the key use cases is gradient accumulation. So I believe in the backwards pass, you need to accumulate into a single slot. Thank you. And so extremely important for that. Massive improvements to nerf.jl and Gaussian splatting.jl, both of which Anton developed. One of the other big changes is moving to Accelerated Kernels.jl. I'm sure plenty of people have heard about this, but Accelerated Kernels.jl basically provides a bunch of built-in algorithms for all sorts of useful operations on the GPU as kernel abstractions, kernels, and such. So AMD GPU now calls into ak.jl for short for these operations. Better performance, better maintenance situation, just all around much better. Additionally, in the future, we might also move our MapReduce, reverse, and find all implementations into AK in some form or another, which will also be good for the other backends, presumably. I'm not sure if anyone ever ran into this kind of image when working with AMD GPU, but this is quite common on laptops and desktops where you run a kernel or an application and you start using up a lot of GPU memory and suddenly your display manager is not pleased with you. And this, thanks to a new caching memory allocator in AMD GPU, this really does not happen as much for real code, which is awesome to see. And generally, you would see stuff like this where the memory just keeps going up. And now with this caching allocator, well, it didn't show up here, but you get a flat line. There are still issues with the GC not running fast enough, but those are work in progress. Kind of looks like this if you're using it. I'll move on from this. There it is. There's that flat line that I was talking about. So this is great for like machine learning models, AI, all that sort of stuff. Much better for Gaussian splatting. Again, one of Anton's packages. So hardware enablement, we now have Julia 1.12 support and thus newer LLVM, which is great for performance and hardware support. We support MI300X, although if anyone from AMD or wherever wants to provide some GPUs for CI, we would love that, or really anything that you can provide. And there's additionally initial enzyme support, although there's still some work to be done there. So you can differentiate through AMD GPU kernels. This is a big one for me. I did a lot of work on this when I was maintainer on, and it never got merged, on being able to actually say when a bounds error happens on the GPU, where did it happen, on which lane, just getting a little bit more information because that first error sucks. So this is beautiful to see. And so this, there's still more work to do. It's hard to do this stuff efficiently, but work in progress. Improved documentation. So moving to Documenter Vitpress. I don't know how to pronounce that. Basically, it's updated documentation. Everything's a lot cleaner, day, night, color changes, whatever. You know what I mean? That's awesome to see. And then, so some future plans are supporting WMMA, basically being able to use built-in matrix multiply hardware and quantization hardware so that you can do these things in Julia kernels, which are very important for all kinds of machine learning and many other kinds of operations. Apparently there's, thank you, flash attention available in an NNOP, and improving that obviously would be big for all sorts of AI machine learning research. Improving enzyme support, multi-GPU programming, which I'm also working on in Dagger, but that's unrelated. And there are some issues with WMMA between GPU generations that need working out. Again, AMD, if you want to help, we would love that. Big shout out to Ludovic Ross, who's been contributing for as long as I can remember. Leonard, Alexis, and all the other contributors. So yeah, thank you so much.
Thanks so much, Julian, for the great talk. So we probably have time for one question while the next speaker, who is me, gets set up. So if somebody wants to handle passing the mic around, go crazy.
And I will do my best to answer your questions, but I'm not fully up to date on everything, so give it a shot.
Yes. All right, one quick question. Well, if not, let's thank our speaker again, and we'll let Katie take over shortly.